Well, hello, fellow peptide enthusiasts, and Murphy and Lucho. Alfredo asked some time ago for me to do a tutorial on how to use Maestro for some of the structural biology features that it offers. And so, Yukon offers a remote desktop called Yukon Anywhere. I actually have Cisco downloaded on my computer, which lets me kind of jump straight into Yukon Anywhere. So you can download that on your own personal machine. You can also just Google Yukon Anywhere and get to it that way. So this is a remote desktop. The files that I'm working with are not actually located on my machine. And so you're seeing like my personal remote desktop, and I can then open up Maestro. And this is an app that you can do all sorts of stuff. I was introduced to it with the class with Dr. Gascon doing some molecular dynamics. So it absolutely has that capacity. But I have found it most useful for just very rudimentary structural biology. Since I work with peptides, they really make beautiful structures in a very quick way once you know how to use the platform. So it takes a while to load, but when it finally does, it will pop up a screen that will allow us to start building a peptide. And I'm just going to repeat what I recently did for my dissertation in building structures for all the peptides I've been working with. So I'm going to use clavin A to build a peptide. And I'm just going to reference its sequence on my dissertation. And so if you see in this screen, make sure I can see myself recording, we can go to the Build tab on Maestro. And we want to select Add Fragments. This is going to let us build a peptide piecemeal. And I'm going to go to amino acids in the Fragments tab. I want to point out two things. If you have this include capping groups checked, it will make sure that every N and C terminus is capped. Clavin A does not have a capped N terminus, and so I will uncheck it for now. And you want to check move selection for chaining. And what does that do for you? So peptides are almost always, the peptide bond is almost always in the trans conformation. Sometimes with prolines, you can have a cis conformation. So just leave that as a trans geometry. The secondary structure, if you just have extended, it will just do, the so-called random coil. And so you can see a number of options here, the alpha helix and the closely related pi and 310 helices. If you are working with collagen, you can make that too. You can make the mirror image of an alpha helix. You can do beta pleated sheets, and you can also build your own custom angles. But I'm just going to make an alpha helix since the clavinins and many antimicrobial peptides are alpha helical. And I'm just going to start building the peptide after I again reference the sequence here. So you're going to have to be comfortable with the codes for the amino acids. So clavin A is going to be valine phenylalanine. I see it's sometimes Maestro will lag a little bit, and so we'll give it a second to think. Yes, and you can see it's popped up in the lower left-hand corner that we have two residues, so we're all good. After the phenylalanine is a glutamine, a phenylalanine, a leucine, glycine, lysine, two isoleucines, two histidines, a valine, another glycine, an asparagine, a phenylalanine, what I'm on residue 16 now, a valine, histidine, glycine, phenylalanine, serine, histidine, valine, and a phenylalanine. And just a quick note, I'm going to now check include capping group to try and derive my amidated C-terminus. Now you see that for whatever reason, it treats the cap as a new amino acid. And that's also something you find when you're doing circular dichroism. It tells you when you read about how to count your peptide bond units to add modified termini. So for whatever reason, I should show this because you're not going to have this by default. So it's possible when you log into Maestro for the first time, you will kind of have that view, and it's very helpful working with peptides if you hit this plus button down here and hit sequence viewer. And so you can see I've got the one letter code down here. And one thing that's very convenient about that is it makes navigation easy. So I can click this cap down here and I can see that, wait, actually, I think I need to hit display the residue. Is that? Hmm. Okay. Sorry. Oh, you know what? I'm sorry. I am rusty on this. So if you don't have it already popped up, you can do Control F to find residue number 24. I believe is what I would like to go to since it's calling that residue 24. Perfect. Um, and I want to get a look at this modified terminus. And it's possible you won't recognize it if this is your first time seeing it, but that is the nitrogen that should be our amide, and they, for whatever reason, have it with a methylated amide. And so I'm just going to highlight that atom, and I'm going to hit the delete button. And you'll see that this is now just a C-terminal amidation. Now, the next thing I want to do is I'd like to, it actually has been constructed in a alpha helical arrangement, but this is a little less appealing to the eye. And so I want to kind of modify this entry. And now I'm going to hit this style button. I'll also mention that you can configure the kind of representation you'd like from all of your atoms. So it defaults to the wire representation, but you can do thin tube, which is just a little thicker. You can do thick tube representation, again, a little thicker. You can do the, I believe it's ball and stick, again, a little thicker, and the atoms themselves are more pronounced. And finally, the space filling model, where it's showing the van der Waal radii for your structure. So I would like to have a ribbon be applied to my structure. And I want the entire entry to be a ribbon. And I want to start by hiding both the backbone and the side chains. Uh, that is kind of interesting, but I'll just hide that too. Um, yeah, not sure. Sometimes it seems to just have a mind of its own. Another thing I should mention is you can go to this workspace tab and you can customize your mouse actions. And so I have a mouse like probably most of you do, where I've got two buttons, a left and a right, and a scroll wheel. And so you should basically select whatever kind of mouse option you have. And you'll see in the default settings that the basically button 1 is the left and button 3 is the right. And so my left click is only used for selecting parts of my entry, whereas the right click allows me to kind of move the frame of the screen back and forth. And buttons 1 and 3, like basically pressing both of them down together, allows me to rotate about like an arbitrary XY plane, as well as the scroll wheel lets you zoom in and out. And so you can then add different modifiers, either adding the shift button to press, the control, or both of them. You can do additional kinds of manipulations. The only one I have found useful today is holding control down and then the left and right button down to do rotation. That's basically how up or down the peptide is. And I'll illustrate that now. So I've got it kind of standing straight up, right click to kind of translate the peptide down. If you would like to change the color of the peptide, no problem. I kind of like blue, but maybe just for fun for this video, we will make it pink. Now, what else? Sometimes you might find that particular residues are of interest to display. And so, my thesis work has kind of been looking at this structural motif that the clavinoids do or do not have. And so, I found it helpful at different points to display certain residues. And so, we can do that like so. So I will use the Control F feature to go to residues that I'm interested in. So I'll start by going to residue 7 because that is where the lysine is. And I'm remembering that for whatever reason, the modification at the end increments every residue by 1. So residue 7 is actually 8 in Maestro's count. So that's my lysine. Yes. And I want to change the selection view from entry to residue. That way I can just select the lysine residue. And I'm going to right click with the ribbon partially highlighted. Or maybe it's left. And if you see display, I can show the backbone atoms for this residue. And I can also hide them. I can also just display the side chain and the alpha carbon atom. And I don't know why I left it as this. I'll do the thick tube representation. And I'll just verify that it's showing that the lysine actually is connected to the alpha helical backbone. That looks pretty good. I'll then navigate to residue 11, which I guess Maestro will call residue 12, to look at that histidine next. And there it is. I see the outline of it. So again, I will. I guess it's giving me a little bit of trouble. Right click is doing it for me with a little bit of resistance. So again, I don't really care to see the carbonyls the way they're oriented. So I just want to check out the side chain. And again, I just want to verify because I had some trouble earlier. Yes, it is still attached, and so is the one above. Um, and then I will go to try to do it faster. Residue 17. Same deal. Residue 21. Okay. Now I'm going to use the scroll wheel to zoom out, translate, and I basically just want to get a decent view where ideally each one of these side chains would kind of be visible, and I think that's okay. Just by a single click on the what is the title of the entry, you can change it. So I'm going to say Clavin A, and I'm going to sort of walk you through how to save a file. I've already done it, so I don't want to do it again. But if you right click, once you're happy with your workspace, you can save an image. I save it as TIFFs, and the reason I do that is I believe the default PNG will not actually let you save a transparent background. No. I mean, it must be the JPEG then. So the ping file is okay. Yes, yes, okay. The JPEG is no good if you want the transparent background. The other thing to say is I do think that the TIFF is actually a higher quality image file. I could be wrong about that, but down here, the dots per inch, I think dots per square inch, something like that. That's basically the resolution of the image. If you have the default 72, that'll be fine for like a group meeting. But if you're going for like publication quality images, you probably should select something like 300 or 600. It's going to make a larger file, but like the very smooth image that you see here, that is somewhere between 300 and 600 DPI. And you could just save it to the uh, remote computer, and you would just um, I have found the easiest way is to just pull up the Yukon email on the remote laptop, send it to myself, and access it from my actual machine to get access to the file. Lastly, I just want to show how easy it is if you're working with a group of similar peptides to make quick derivations to it. And so clavin A and clavin B differ by a single amino acid, and it's at the 7th residue. So if I want to duplicate an entry, I can come up and right click on the entry. And there's a duplicate option. I want to select this. I want to duplicate it as an ungrouped entry. That basically just means probably what you're thinking of when you think about duplicating something. You don't want any sort of kind of like folder subfolder organization to develop, and that's what's going to happen if you do the grouped entries. So I'm just going to highlight the second one, left click, and rename it clavin B. And very easy, I'm going to navigate to residue 7. Again, it's calling it 8, and I want to make sure over in the structure hierarchy view that I'm actually manipulating what I'm calling clavin B. So I'm just going to right click the, oh, must not be the, oh, there we go. Yeah, I'm going to right click the residue and not the part of the helix that's highlighted. And check it out. There's a mutate residue selection. And so I'm just going to change it to arginine. And you'll notice that everything else is the same. And it's even the same kind of representation that I had selected for clavin A. And so basically I did the hard work to find to generate the first peptide, and the others are a cinch. And you can also, like, if you want to look at like certain residues to make sure all of them are represented in a view that is clear, one of the things you can do is do like a shift, click, 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 and then come over here to the zoom option that lets you zoom on selected atoms. Yeah. I don't love this option because it often means that the full peptide is not in view, but you can do that. I think that's all I want to say for now. I hope this was helpful, and feel free to ask me questions. Thank you.